And this generation does not intend to founder in the backwash of the coming age of space. We mean to be a part of it. We mean to lead it. He said because it is there. Well, space is there.
Hello everyone, welcome to That Space Show. I'm your host as always, Nick. Thank you guys. And this is now episode 6, my favorite number. And we're going to be looking through the weekend of the 12th through the 15th, which today is April 15th, Monday, 2024. And I noticed only 28.4% of you are subscribed to the channel. I mean, if you like space news 3 days a week, why not just subscribe? I mean, you don't have to. I'm just suggesting if you really like space and news. So, without further ado, let's just honestly get straight into it. And now today, we're going to have the moon at the first quarter. And we're going to have Messier 83 going to be well placed, so deep space people, check that out. And then Wednesday, we're going to have Messier 3 being well placed as well. A lot of Messier. And then launches, we have the Falcon 9 Block 5, Starlink Group 6 through 49. And I have that video on the screen for everyone to look at.
2, 1, ignition, and liftoff of Starlink 649. A Falcon flies for the 20th time.
And then Monday, we're going to have the Long March 2D unknown payload, which is actually going to be today at 12:10 a.m. Eastern Time Zone. Check that out. And then Wednesday, we have the Falcon 9 Block 5 Worldview Legion 1 and 2, which is going to be Wednesday at 2:30 p.m. Eastern Time Zone. And the Falcon 9 Block 5 Starlink Group 6 through 51, which is going to be on Wednesday again at 5:24 p.m. Check those out. Good times. Not going to lie. And our first news story of the day, fast radio bursts. Fast radio bursts are the most intense radio explosions in the universe. Discovered in 2007, scientists still haven't found the origin for these. They're said to originate from spaces such as black holes or neutron stars. This is because of the size of the source of the burst should be smaller than the speed of light times how long the burst lasts. This is because these bursts do not last that long, and based on how much energy there is in a short amount of time, suggests it should be coming from a source like a black hole or neutron star. Scientists expected these bursts to have fast spin, which produces like a energy pattern like a heartbeat. This is seen in black holes and neutron stars, yet they were not able to find any patterns with the fast radio burst. A group of scientists in China decided to study the chaotic variable, which is unpredictability of the burst, and the randomness of them. They were able to find that these bursts are not really chaotic, but more random then. Thus, this means they could originate due to a cause. This could help us understand where they come from. And now a near collision. It was revealed that a broken down Russian satellite named Cosmos 2221 came very close to NASA's Time spacecraft, only 10 meters away, which is basically touching in space. This crash could have caused debris to collide with the spacecraft and ended up risking lives. Seems like it should be a bit more common considering we have 10,000 space objects up there. That is a lot. And then Sierra Space released a new concept for doing on-demand cargo from Earth's orbit. Weird, huh? Somehow they plan to drop it from the cargo carrier in orbit within 90 minutes of requesting it here on Earth. They call it the Ghost platform. It would basically deorbit the satellite and then let the payload re-enter the Earth by a protected thermal shield. This would aid in the military and so much more. This is still in the works, of course. There's still a lot of issues that need to be addressed, like landing, but this idea is only getting started. Never thought you'd see that, right? And then, fake solar flares. The purple everyone saw around the solar eclipse was not actually a solar flare, rather a plasma bloom. The sun's corona, which is an outer layer of the sun's atmosphere that extends millions of kilometers into space, it's made of extremely hot ionized gas, or plasma. Plasma is basically a state of matter where gas is so hot that it loses electrons and turns into kind of a soup of charged ions. This plasma is constantly being moved as the magnetic activity and heat causes it to. So very interesting. Even that we could see that. And now, seismic sensor. During the 1970s, scientists placed seismometers on the moon to study moonquakes. These could have been caused due to temperature changes, the Earth's gravity, or the moon cooling and contracting. We have discovered a new way to study this using distributed acoustic sensing, DAS. DAS works by sending lasers through a fiber optic cable and measures how light moves and it shakes. They were able to test this in Antarctica and it worked great. The time travel of light along with the cables of the motion tells us the motion of these waves. So very cool. And exoplanet versus star. In the constellation Virgo, the exoplanet WASP 39b orbits the star of WASP 39. The planet, which is a gas planet, takes about over 4 days to complete an orbit. A study found that WASP 39b had evidence of water vapor, methane, CO2, and more, but they were not able to reproduce these observations. Researchers at the Max Planck Institute for Solar System Research decided to focus on how the brightness of stars changes over time to see if maybe this was the cause. When a planet passes in front of its star, it causes a dip in brightness, which can tell us about the size, atmosphere, and orbit. Also, when a planet is in front of its star, it causes the star's light to pass through the atmosphere where different gases absorb different colors of light, and it creates a pattern which tells the scientists the composition. Though the evidence was not matching up, researchers realized they forgot about the star's magnetic field. Magnetic fields can affect brightness over time. Think of a star like a big ball of glowing gas, similar to a giant light bulb. Now imagine this ball of gas has kind of an invisible force field around it, called the magnetic field, which affects how the light shines from different parts of the star's surface. The outer edge of the star is darker than the center because of the magnetic field. By including the magnetic field, these observations matched up and they were able to solve it. Very cool. And tidal stellar streams. Astronomers in China have made an exciting discovery using from the Gaia satellite. They found a new trail of stars in the sky which is called a tidal stellar stream. These streams are formed from the leftovers of ancient events where galaxies collided or merged. This new stream they found is in the northern part of the sky and it's not very dense, but it stretches out in this area. It stretches about 80 degrees long and 1.7 degrees wide. And by studying from the 7 stars in the stream, they found that the stars had low metallicity, which means they have fewer heavy elements. This suggests that the trail may be from an old event in the galaxy history called the Sequoia merger. The merger just pertains to when the Milky Way collided with smaller galaxies, and to measure degree, it basically means it stretches across 80 degrees of the sky when we look at it from Earth. And overall, this discovery shows that there may be much more ancient streams out there waiting to be found. And escaping oxygen and carbon, Bepi Colombo, a spacecraft on its way to Mercury, made a quick stop on Venus and made some fascinating discoveries about how gases escaped from Venus's atmosphere. Scientists found that carbon and oxygen ions are being sped up to the point where they can break free from Venus's gravity. This has been the first time that this has been observed in heavy ions. One guess is that electric forces between solar wind and Venus, or centrifugal forces, are flinging them away from the planet. While Venus doesn't have a magnetic field, it does have something similar to a magnetic bubble created by interactions between charged particles from the sun and particles in the Venus's upper atmosphere. The spacecraft threw through that bubble and gathered data about the charged particles. This will allow us to help understand how Venus's atmosphere has changed over time and how it's lost most of its water from its early life stages. And does anyone remember that gamma ray? Well, back in October 2022, an international team of researchers observed the brightest gamma ray ever recorded, GRB 221009A. Gamma rays are a type of electromagnetic radiation like X-rays, which have the highest energy and shortest wavelength of any other type of electromagnetic radiation. Then gamma ray bursts are the most powerful explosions in the universe. They're basically bursts of gamma ray radiation that last from milliseconds to several minutes, and they're usually associated with the collapse of massive stars, the collisions of neutron stars, or the birth of new black holes. Gamma ray bursts can release more energy in a few seconds than our sun will emit in its entire lifetime. This gamma ray burst was dubbed the boat, which is the brightest of all time. They would later confirm this gamma ray burst did come from a collapsing star that was exploded as a supernova, which was discovered. Yet one issue remained that there was no heavy elements like gold or platinum that came from this collapse and the explosion. They have confirmed that neutron stars, well, mergers, do make heavy metals. They aren't sure if the gamma ray burst or the supernovae did. They're checking this source because of the rapid neutron capture, which states that neutrons can be bombarded at such a rapid rotation that they turn into a proton, thus into a heavy element. They will continue to watch these structures for evidence of heavy metal formation. Very cool. Who knew? And solar winds. A team at university from Vienna has directly detected solar winds from 3 sun-like stars. Solar winds are created when a star's outer layers become very hot. This causes particles like protons and electrons to move rapidly and escape from the star's surface. These particles form a continuous stream that flows away from the star into space. The strength of the solar wind depends on factors like the star's size, temperature, magnetic activity, and more. These winds can carry material and energy, influencing the environment around the star and affecting nearby planets and objects. They achieve this by observing the X-ray emissions from the astrosphere surrounding the star. Astrophysically hot plasma bubbles formed by the solar winds blowing into the interstellar medium. Studying these winds is crucial for understanding the evolution of stars and planets. And who knew, solar winds can actually strip away planetary and celestial body atmospheres. This is done in many ways, but allows molecules to escape the atmosphere and gravity. Yet, it is hard to detect these winds because of the composition being only protons, electrons, and charged ions of oxygen and carbon. XMM Newton Space Telescope, which was able to find out about these winds and then estimate the amount of oxygen, allowing for the calculation of the total mass of the wind. They then found the mass loss rates of these stars. This opens up a new gear of solar wind studies, as this is the first directly analyzed solar wind emission of these sun-like stars. Very cool. And the clash of stars. Recently, astronomers looked at a pair of stars in the middle of a cloud of gas and dust. Usually star pairs are twins, but HD 148937, one star seems younger and has a magnetic field unlike its twin. It was said this system actually had 3 stars at one time until one of them merged. This formed the cloud around these 2 stars remaining. This system seems unique as these stars should have formed at the same time, but the larger stars seems younger, which means it could actually be explained by the merger. Actually, when stars merge, it rearranges their internal structures and it led them to almost a resetting clock in certain characteristics. These stars are actually the same age, but the characteristics change, which makes the other one look a lot younger than the other. This could also be supported as the formation of magnetic fields can be made due to mergers. Astronomers are still looking into this. I'll let you know if anything pops up. And JUICE mission. In April of 2031, ESA's JUICE mission will have a close encounter with Jupiter's moon Callisto. There's a communication delay though, which means that JUICE will have to use its own navigation capabilities. The team has tried to run some simulations of this encounter, and it honestly went perfectly. More tests will be done, but when it's time for Callisto encounter, I honestly think JUICE will be ready to go. And Winter Tech. Researchers at Kennedy Space Center are trying to find a solution to the dusty surfaces of Mars and the Moon. They have come up with the Electrodynamic Dust Shield, EDS. On the Moon, this dust is sharp and clingy, which could get stuck and cause issues for the equipment and the astronauts. This uses electric fields and transparent electrodes to remove the dust. The EDS creates an electric field around the suffrage and interacts with the charged particles in their dust. This electricity pushes them away as repulsion happens. This will be tested soon, but in the test it has succeeded. Wishing you luck, JUICE. Oh, sorry, the technology. Whatever. Orion. In a video, Orion has been tested in the altitude chamber to test how it handles electromagnetic interference and compatibility. Artemis is almost underway in 2025. I'll show you a video of that. And ancient galaxies. Last September, the James Webb Telescope found a really old, huge galaxy called James Webb Telescope ER1G. This galaxy was formed when the universe was only a quarter of its current age. What's cool is that it comes with its own effect called the Einstein ring. This happens when the galaxy acts like a giant magnifying glass, bending light from far away so it looks like a ring. Gravitational lensing happens because of the way gravity works in space. So again, imagine space as a giant fabric, like a trampoline. Something really heavy, like a massive galaxy, sits on this fabric. It creates a dent in it. Now, if light from a distant object passes by this dent, it gets pulled and bent by the gravity of the massive object. Just like a marble rolling around the edge of a trampoline. It's going to get pulled towards that heavy object in the middle. It's really something Einstein predicted in his theory of gravity. Now, this ring has two kinds of things making it up. Regular stuff like stars and something called dark matter, which I'm sure you know. Scientists noticed that there's more dark matter than they expected. They think it might be because of the regular stuff is squishing the dark matter together, making it denser. This finding is important because dark matter is this mysterious stuff we can't directly see, but we know it's everywhere. And the ER1G, which formed about 3.4 billion years after the Big Bang, gives us a special chance to study dark matter up close. The James Webb Telescope, which NASA launched in 2021, is like a superpowered time machine. It's letting us look back to see what the universe was like when it was young. And scientists are excited to keep using it to uncover the secrets about this dark matter and more ancient galaxies. That was really cool to find out. Nuclear fission. South Korea's artificial sun, they like to call it, just reached a new milestone in their fusion energy research. Their K-star reactor managed to heat up a plasma loop to cool 180 million degrees Fahrenheit, 100 million degrees Celsius for you people out there, and keep it there for 48 seconds. This breaks their old record of 31 seconds set back in 2021. Why is this a big deal? Well, scientists have been chasing the dream of nuclear fission for over 70 years. Fission is the process that powers stars, where hydrogen atoms smash together to create helium, releasing a ton of energy in the process. Picture the K-star reactor like an oven, but instead of baking cookies, it's cooking up something named plasma. And again, plasma is hot, electrically charged soup made of tiny particles. Now, inside the K-star, there's a special chamber shaped like a tunnel. Scientists are going to pump in a bunch of gas and zap it with electricity, turning into super hot plasma. To keep this plasma contained in there, they have to use powerful magnets. Once the plasma is all heated up and trapped, it's like having a mini sun inside the reactor, thus the name, artificial sun. And when the plasma gets hot enough, the atoms start smashing together, just like in real stars. This process releases a ton of energy. The goal is to keep the plasma super hot and switch together long enough for these fusion reactions to happen. That's where the challenge comes in. Scientists are always trying to figure out new tricks to make this plasma stay hot and controlled without burning through the reactor walls. And this could honestly be a new way into the use of clean energy, which we've been looking for a long time. I mean, fossil fuels aren't going to last us forever. I mean, right? How much more can we possibly use? And with that, I know it was very long. I didn't expect it to be this long of an episode. I mean, I guess the weekend was packed with news. I mean, a lot of great news, in my opinion. So, with that, that's going to be the end of this video. Make sure, everyone, if you can, hit that like button, subscribe, share if you can. Shout out to the 28.4% of people that are already subscribed to the channel. You're the real ones. I mean, everyone's a real one. Even if you're not subscribed, I'm happy that you're here watching my video. And, well, I'll see you guys on Wednesday for the next video. Hopefully there's some cool stories out there. And without further ado, be bold. Be original. Be invincible.